Hi everybody, I'm Mike Poland, the scientist in charge of the Yellowstone Volcano Observatory, and this is the monthly update for October 1st of 2021. I'm coming to you today from the warehouse at the Cascades Volcano Observatory. Now this is where we store a lot of the material and equipment we use for monitoring volcanoes throughout the western United States. And we're gearing up for some field work that's going to happen later this month. And we always go out to Yellowstone in October to harden all of the monitoring equipment that we have out there. Yellowstone has some really harsh winters, a lot of snow, very cold, so we want to make sure things are going to work throughout the year. Now, part of the work we do in October is to remove what we call the semi-permanent GPS network. Yellowstone has dozens of GPS stations that are continuous. They're anchored into the ground, and they're radioing information out in real time 24/7, 365 days a year. But we supplement that continuous network with what we call a semi-permanent network. These are stations that we install every May once the snow melts, and we pull them in October. They're not connected by a radio link, so we have to pull them out to get the data. And we put them in places where we don't have continuous stations. Maybe the radio connection isn't good, or the environmental impact of a big continuous site would be a little bit too much. So we've got 17 of those stations throughout the Yellowstone region. And those stations look something like this. There's a box that has the batteries and equipment in it that includes a GPS receiver. This is where the data are actually stored. Now, attached to the ground is one of these small antennas. And these antennas actually collect the information from the satellites and then store it in the receiver. Now, in addition to the batteries in the box, we have a small solar panel that sits on the ground next to the antenna that provides power. Now, we install these things in May, remove them in October, and when we pull all of this equipment out, the only thing that remains is a very small pin on the ground, which we can come back to the following year. There's two main purposes for this semi-permanent GPS network. The first is to look at changes that happen from year to year in how the ground is moving. We can take the position of the station in 2020, compare it to that position in 2021, and see how the ground moved in the time between. When we do this at all 17 stations and combine it with the continuous GPS network, we get a very nice view of Yellowstone deformation. But we can also see subtle changes that the continuous network might not be able to see. And a good example of this is actually the deformation that's caused by Yellowstone Lake. Now, every spring when the snow really starts to melt, Yellowstone Lake rises, it fills up with water. And then throughout the rest of the summer, that water drains out of the lake and the lake level goes down. Well, the weight of this water actually causes deformation. As the water rises in the springtime, more weight is put on the ground, and the ground around the lake actually subsides. And then as the water drains out of the lake, the ground rises because some of that water weight is removed. We've actually seen this with the semi-permanent GPS network. There are stations, when we deploy them in the spring, they're going down along the shore of the lake, just along the shore of the lake. And then they pop right back up. And how they move, going down and then up, corresponds exactly to the water level in the lake. As the lake level goes up, the ground goes down. As the lake level goes down, the ground pops back up. So that's just one of the really neat things that we've been able to see with these semi-permanent GPS stations. Okay, well now let's talk about what's happened in Yellowstone over the past month.
Seismicity picked up a bit towards the end of September, but it's still within normal background levels. The University of Utah seismograph stations, which is responsible for the operation and maintenance of the Yellowstone seismic network, located 283 earthquakes during the month of September. The largest was a magnitude 3.2 earthquake on September 8th, and that occurred on the Pitchstone Plateau. There were also 4 swarms that occurred during the month. The largest swarm had 153 earthquakes and still counting. That started on September 16th and is ongoing, just here a few miles to the east of Madison Junction. A swarm of 17 earthquakes began on September 28th and is also ongoing just to the northeast of West Yellowstone. This is typically the most seismically active area of the park. 16 earthquakes have been located so far in a swarm beneath Yellowstone Lake. That also started on September 28th and is ongoing. And then finally, there was this swarm that was on the Pitchstone Plateau that included the largest event of the month, 14 earthquakes there on September 8th. Turning now to deformation. This is the vertical deformation at the White Lake GPS station. Each one of these blue dots is 1 day, and this data goes back 2 years. So you can see 2 years of subsidence and uplift. Every time the trend is down, that's subsidence, and the trend being up is uplift. The overall trend during this 2-year period is subsidence, but you can see during the summer times there are these brief periods of a stalling of that subsidence, or even slight uplift. And that's caused by groundwater that's being recharged by all the snowmelt that slowly percolates into the subsurface. So we aren't seeing any real change in the overall patterns here at White Lake on the east side of the caldera on the Sour Creek Resurgent Dome. It's overall subsidence at a rate of about 2 to 3 centimeters a year. That's about an inch a year. Moving to the other side of the caldera and the Mallard Lake Resurgent Dome near Old Faithful, the same sort of pattern emerges. Overall subsidence with a slight change or shallowing of that trend during the summer months. And you can see here in September of 2020, the signal gets a lot better because there were some trees that were cleared in the area of the GPS station due to a fire that was burning nearby. The trees were cleared to remove the fire load from the region, and that resulted in a better GPS signal. And then there's Norris Geyser Basin. Now, Norris had seen uplift from 2015 to 2018, but over the last several years, there's been really no change at Norris. Here, the 2 years starting in late 2019, going into the end of September of 2021, again, we see basically no change at Norris. It's a really flat line, so no deformation at Norris. And then finally moving to Steamboat Geyser, everybody's favorite geyser, we were looking at perhaps a slowdown. There had been no eruptions at all in August, but Steamboat, who knows, maybe turned it around a little bit. We had 2 eruptions of Steamboat in September. One here on September 11th, and one here on September 28th. This is the temperature record in the outflow channel for Steamboat. All of these little variations are minor eruptive activity that leads up to the major, and then once the major happens, things calm down and we see just daily temperature variations, and then more minor activity leading up to the major. So it'll be interesting to see during the month of October whether we see more minor activity, which might indicate that we would be building towards yet another major eruption of Steamboat.
Well, that does it for the monthly update for October 1st, 2021. Now remember, if you have any questions at all, feel free to email us anytime. You can reach us at yvowebteam, all one word, at usgs.gov. Until next month, stay safe, stay healthy. We'll see you in November. Bye-bye.